and welcome to Zoology Live 2022. I'm Ros Wade, I'm the Learning Officer here at the Museum of Zoology, and I'll be your guide this week as we look at wildlife past, present and future. Today we are here at the museum to explore the collections we have that were made decades or even centuries ago and what they can tell us about wildlife in the 21st century. Tomorrow we'll be at the Cambridge University Botanic Garden and we'll be uncovering the work of scientists monitoring present-day wildlife to better understand biodiversity today and how we can protect it for the future. So make sure you join us then at 7 o'clock on YouTube. The festival concludes at the weekend with our BioBlitz. This is a 24-hour species count at the Cambridge University Botanic Garden from 5 o'clock on Friday the 24th to 5 o'clock on Saturday the 25th of June. And here's a little taster of what you can expect if you come along. At the beginning of that film, we saw some beautiful butterflies being recorded at the Botanic Garden. Here at the museum, we've been running a research project called Butterflies Through Time, using our collection of British butterflies to explore habitat change and inform conservation. Here's research assistant Evie Crouch to tell us a little more about the project. And Evie will be joining us live after this short film to answer your questions about these amazing insects. So do pop them in the comments on YouTube.
Hi, my name's Evie. I'm the Research Assistant for the Butterflies Through Time project at the Museum of Zoology. Today we're here at the Cambridge Botanical Gardens and I'm just going to tell you a little bit more about the project. So the project was started over 2 years ago with the aim of increasing access to museum specimens. So while we have 2 million specimens at the museum, actually less than 1% are on display due to storage and these being put away for research, and just because there isn't enough space. So this project, we're aiming to link these museum specimens to modern day conservation and hopefully bring people closer to nature in the process. So while we might think of butterflies as loving these warm, sunny, open areas, actually this doesn't do it for all specimens. So the speckled wood, for instance, is a woodland specialist, and it prefers much more shaded areas such as this one. The speckled wood, though, in recent years has actually been increasing due to climate change because it has upped the amount of its favourite habitat, sunny woodland clearance. But not all species are benefiting from climate change. So for instance, the painted lady. The painted lady is actually one of our 2 migrant species, and it travels from the UK from sub-Saharan Africa. But while it's making this incredible journey, heightened levels of CO2 is actually affecting the amount of foliage its caterpillars can munch on, and therefore affecting its development. But painted ladies aren't the only species being impacted by human activity, and far from it. Another example is the meadow brown. So the meadow brown loves huge swathes of wildflowers such as these, and its favourite habitat are wildflower meadows. But with the intensification of agriculture throughout the English landscape, we're seeing far, far less of these. And with that, we're seeing a decline in the common meadow brown. While it's still a common species, we're actually seeing a decline in its abundance.
I'm joined now by Evie. Hello and welcome to Zoology Live.
Hi.
So here at the Museum of Zoology we have quite a collection of British butterflies. Can you tell us a little bit more about them and what they can tell us about butterflies today?
Yeah, so we actually have around 15 to 20,000 specimens down in the insect storeroom. So while we have the British butterflies on display in the galleries, there's actually a lot more going on downstairs. So these specimens, some of them date back around 200 years. So they can be really old and actually tell us a lot about the story of change of what's happened in between. So in this way, they can act a bit like time machines. When we think about the change that's happened to our environment over the last 200 years, we've got like the Industrial Revolution and everything that's been going on. If we take Cambridge, for instance, as an example, we can see there's widespread habitat change that's been going on. So our viewers might be familiar with the fenlands that we used to be swathes across East Anglia, ranging from Lincolnshire down to like Norfolk and parts of Suffolk as well. So actually these were drained starting in the 1600s and sort of ranging from to the 1800s, where they drained for their rich and fertile soils to make way for our farmland that we know is very prevalent around Cambridgeshire today. So with this change, we know that a lot of butterflies that used to be prevalent in the fenland landscape have actually gone extinct, such as the swallowtail, for instance.
Oh, it'd be amazing to see swallowtails in Cambridgeshire. I've never seen a swallowtail butterfly. They're beautiful.
No, neither have I. I look forward to it. I'm hoping to one day I will. It's found in small pockets of the Norfolk Broads, so I'll have to make a little trip one day and see it. It's on the bucket list for sure.
Definitely. So butterflies, they're good. They're a good animal to study then, to get an idea of what's happening to habitats.
Definitely. So they're actually an indicator species. Mm-hmm. This is because they're very sensitive to environmental change. This is because they have 4 stages to their life cycle, so ranging from the egg to the pupa, the caterpillar, to the chrysalis, and then to the adult stage later. And each of these stages have their different sort of requirements, especially with the caterpillars, which can actually have a totally different food source and in terms of the plant species to what the adults need to drink the nectar.
Yeah.
So, yeah.
Yeah, oh, that's fantastic. So, yeah, really beautiful, but also really useful for us to look at then, the butterflies.
Yeah, definitely.
Yeah. So, one thing you mentioned in the film as well is, I always find it amazing that there are butterflies that migrate, and they migrate long distances. How are they actually able to do that?
Yeah, it is really incredible. So a bit of an underdog that people might not know is the painted lady, and it does this most incredible migration journey. It comes over to the UK from sub-Saharan Africa sometimes, so you're reaching even all the way down to like, tropical African regions, which is the most incredible story. It does often get upstaged a bit by the monarch, which we like to think of as this like amazing journey, which it does do, and it does do in one generation. But actually, because the painted lady does this incredible journey, it's able to do travel like over double the distance basically, but it does it over 7 generations, which I think is almost more incredible because they start from scratch basically. They stop off at little pockets of the way on the journey, and the fact that they're still able to navigate and know where they're going is just incredible. So
yeah, I don't think I'd be able to, as a newly formed adult, know which direction to fly in. Yeah, that's amazing. So one question that I'm asked quite a lot in the museum is how long do butterflies live? And I guess one thing I was always wondering is, do they spend longer as a caterpillar or as an adult with wings?
Yeah, so the answer is it totally depends on the species. So some species, they have a really short lifespan, whereas other species can live up to 1 year, basically. So I'd say around the average lifespan for the butterfly, the actual adult, is around like 2 weeks sort of thing. However, it does, as I say, depend on the sort of taxonomic route, because you've got like the nymphalids, so these are our large butterflies like peacocks, like the painted lady, so these beautiful, colourful...
So the big showy ones.
The big showy ones, that's exactly what it is. So they often actually overwinter as adults, so therefore they'll have like a longer lifetime as adults, whereas most butterflies will overwinter as caterpillars. So it sort of depends on that trade-off on where they're overwintering and what stage.
Yeah, that's also amazing, being able to overwinter, like insects overwintering like that. Yeah, I always fancy the idea of hibernating. Do they kind of hibernate as well then?
Yeah, it's sort of a bit like a hibernation, but for insects. So they just enter a more dormant state over winter, but they can actually still be disturbed. So a lot of people might find the nymphalids, so like a peacock, for instance, can overwinter in sheds. Quite often you'll find them, or in your garages, and especially when people turn on the central heating over winter, it can sort of disturb them because all of a sudden they think it's spring, they come out. So they are a bit sensitive like that. If you do find one, just sort of put it in a box and just try to place it back outside or under some shelter or something in a tree.
So they don't get too sort of active and sort of burn all their energy off, I guess, is that?
Just because if they came out and they're obviously they wouldn't be in sync with the flowers at that time, because they would think it would be spring and they could go and drink nectar, but then they would be out of sync with the timing of the wildflowers.
Okay, yeah, of course. So what's the best way for us to go about spotting butterflies? Do you have any top tips to go and see butterflies?
Yeah, I mean anywhere where there's lots of wildflowers really. So sort of big open spaces, they love obviously a lot of sunshine, but also a lot of structural variation, because while they're ectotherms, so they actually rely on external sources for to regulate their body heat. They need to obviously warm up and bask in the sun. We all know the basking butterfly behaviour that they love to do, but they actually need some structural variation, which means that it creates microhabitats in the environment, which also means that they can cool down. So they have a whole swathe of habitats to sort of vary themselves in as well as obviously having a lot of variety of wildflowers will definitely help.
Okay, so find somewhere that they're going to get some food, and a nice sunny day, then I'm guessing is a good day to go and see them.
Always the best thing about being in butterflies or doing any butterfly research is that we get to sample them from 10 a.m. to 4 p.m. Then it's always on nice sunny days, so it's always a good time for doing the butterflies.
How many types of butterfly do we have in this country? Because you've mentioned a few there. Are they really diverse, or are they sort of, how diverse are they?
No, we don't have that many in comparison to a lot of the tropical countries, obviously. So we actually have 57 species, 59 with the migrants as well, so around 60 species,
Okay. And what about moths as well? I mean, do moths, people who work on moths, do they feel a little bit left out sometimes? Because butterflies look so showy and and pretty, and they get a lot of press, and moths don't tend to have quite such good press behind them.
Yeah, I imagine so, yeah. The moths, obviously, the butterflies are the big showy ones. They've got the beautiful colours. They instantly attract, and what can I say? I'm a sucker for all that colour variation, for sure. Moths, there's a lot more of them as well. So I think a lot of people who do end up getting into moths might have started on butterflies as well. They're a really good starter species because we don't actually have that many species in the UK. And because you identify them by their wing pattern and the colours, they're sort of instantly recognisable as well, and a real fan favourite with the public. So once you sort of get into the butterflies and you've mastered around the 60 species, you can then sort of move on to the moths and then keep going on from there.
So a good starter species then if you want to get into entomology. And my last question for you is, what can we be doing to support butterflies in our own green spaces? Are there things that we can do to help butterflies out?
Yeah, definitely. If you have access to your own green space, people may or may not be aware, but last month was the month of No Mow May, which is a campaign by Plant Life to get people to hold off mowing for the month of May. And it is very effective, essentially, because, we all love to mow down our lawns in the country. We actually I don't think maybe necessarily think about why we're doing it or that sort of thing, or actually the impact that we could have if everyone in the country sort of let their lawns grow a little bit more. We can get those wildflowers coming through, especially in a month like May. Like in spring, this is going to be really important for the butterflies coming out of over a wintering period or coming over from migrations, like the painted lady, for instance, and then that they can instantly have that abundance more of wildflowers. And you could even carry it on. Who's to say that you need to start mowing again? I mean, you could always leave it a little bit, or you could, for instance, just leave a patch unmown year round instead of like having a bed or whatever. It could just be a wildflower patch.
Wildflowers. Yeah, one thing I've noticed actually around Cambridge, and I hope it's in other cities as well around the UK, is there's quite a lot of the verges now are being left, and they're not being manicured and mown right down, and they're just being left. And I personally think it looks a lot better as well as supporting wildlife. I much prefer the way it softens the way the city looks.
Definitely, I mean, it's free, it's better for nature. I mean, I think there's lots of studies that more wildlife and that brings about the better diversity, and that has massive impacts for people's mental health as well. So
good, all right.
Yeah, exactly. I guess it's your own personal taste, but I definitely think it looks better, but maybe I'm biased.
No, I absolutely agree. And thank you so much, Evie. That's been really, really fascinating.
No worries.
So naturalists of the 19th century, dating back to when we have some of our butterfly collections going back to, they often kept detailed notes about the wildlife that they saw. And this information is invaluable to us today as a resource detailing what habitats were like over 100 years ago. But have you ever thought about having your own wildlife diary? It's not only good for keeping tabs on what you've seen, but I also find it's really good for well-being, and it's something that I try and do when I can. So here's one that I started in 30 Days Wild, so back in June. This is a Wildlife Trust programme. So here I just have a sketchbook, and I write in it just a few of the things that I see. I particularly like it when I go out pond dipping. There's a baby newt, and some of the birds that I see and the flowers and things like that. So it's a really simple thing to do, and we've got a few top tips on how you might keep your own wildlife diary. So one thing about collections like ours at the Museum of Zoology is how they can transport us around the world. Our Assistant Director, Jack Ashby, has long been fascinated with the mammals of Australia. He's going to show us here some of our Australian mammal collections at the museum and tell you a bit more about them. Then Jack will be joining us live after this short film to answer your questions all about monotremes and marsupials. These are really marvellous mammals. So do pop them in the comments on YouTube.
Hi, I'm Jack Ashby and I'm the Assistant Director of the Museum of Zoology. And my main interest in natural history is the mammals of Australia. My very favourite animal in the world is the platypus. I think they're absolutely amazing. I've been researching them for the last few years for a new book, Platypus Matters, and they show kind of absolutely incredible adaptations to life on Earth. People often describe them as weird or primitive or strange and bizarre, and I think that isn't the way we should be framing animals, but they do some pretty incredible things, such as their beaks can detect electricity, so they're some of the only mammals that detect electricity. As you may know, every muscular contraction in the animal kingdom is controlled by electrical impulses, including our heartbeats. So when platypuses dive, they close their eyes and their ears, and they can sense the world in electrical impulses, and they can find their prey, which is crustaceans and worms and snails, and they can find their prey by sensing those electrical impulses using their bills. And then when they find them, inside their bills, they don't have teeth. They've done something pretty amazing evolutionarily, and that's to get rid of teeth and replace them with these little horny ridges which crush up these prey. And that's very, very clever, evolutionarily speaking, because it means that if they're eating tough animals like snails or crayfish, or eating sand and silt, and they get in their mouths, it doesn't wear down their teeth. Instead, they have these horny ridges which can be regrown. And their feet are incredible too. They can dig, especially female platypuses like this one, can dig for between 10 and 30 meters underground, which for a 50 centimeter long animal is pretty amazing. And they do that with these really long nails and really, really strong muscles. But as you can see on their specimens, they have webbed feet. So that's for swimming, so they can use webbed feet when they're swimming, but when they're on land digging, they fold their webbings away to reveal these massive claws, which help with that digging. The other thing I want to talk to you about is what we can learn from museum specimens. And I've brought some of our collections here. So in the course of researching Platypus Matters, I came across this specimen and others like it, which we had been kind of forgotten about, if you like. This is a baby echidna, which is called a puggle. Echidnas are related to duck-billed platypuses. They're kind of spiny, egg-laying mammals, but it took about 85 years to prove that some mammals lay eggs. And this was one of the specimens that helped make that proof, that a scientist from Cambridge called William Caldwell went to Australia after many other people tried to find proof that platypuses and echidnas lay eggs. And he finally did so in 1884 with this specimen and others like it, when they found an echidna with an egg in her pouch and another in a nest, and a platypus with an egg in its nest and another inside its body. Final thing I'm going to show you is this specimen, which is pretty exciting if you're into Australian mammals, because this is the pouch of a thylacine, which are also known as Tasmanian tigers. Now, thylacines are one of the most famous extinct animals. The last known individual died in 1936 in a zoo in Hobart, but they are kind of stripy, dog-shaped marsupials. And this is one of their pouches, and what's really interesting about it is, if we look closely, we can see that the teats inside are different sizes. So the two at the top are very small, the two at the bottom are really big. And that means, quite sadly, when this animal died, it had two large pouch young, so it would have had two animals in its pouch, two babies in its pouch. And at some point in the recent past, it had also had two other babies, but it had lost them. So when marsupials are suckling with the babies in their pouch, the teats grow with the babies, and as these teats are so big, we know that the babies are quite big. So this kind of tells us a bit about the life of an extinct animal that we wouldn't necessarily have known, that they could have had up to 4 babies, but this one at the time only had 2. So marsupials, I think, have the most incredible reproductive system. They give birth to tiny, tiny young just after a few weeks. So the biggest marsupial today is a 90 kilo red kangaroo, the skeleton behind me. They give birth after about 5 weeks to tiny babies that are just a few millimeters long. And these animals, despite being so small, are able to climb on their own all the way into the mother's pouch and attach to a teat there. And something really interesting that kangaroos do is that they'll have that one tiny baby that's just crawled into the pouch, and that baby will be suckling on one tiny teat. At the same time, they'll have a much larger baby that's still suckling, but lives outside the pouch. It's got too big, so maybe about this big, and they'll still be sticking its head in and suckling off a much, much bigger teat. And then kangaroos can do something really amazing, which is to hold a third baby in kind of suspended animation. So they'll mate soon after giving birth, and then they'll pause their pregnancy, waiting for a teat to become empty. So that little embryo will be waiting inside the mother's womb for the baby outside the teat to finish suckling. And as soon as it's finished suckling, the hormones will switch, and the pregnancy will recontinue, and then a few weeks later, another tiny baby will be born. Absolutely incredible kind of non-stop conveyor belt reproductive system that kangaroos show.
And now I'm joined by Jack Ashby. Hello, Jack.
Hey, Ross.
Hi. Thank you for joining us this evening. So my first question to you is, why Australian mammals? What is it about Australian mammals that really sort of piques your interest?
I guess the first thing to say is Australia is the only place, and New Guinea, not Australia, it's the only place in the world where you find all three major groups of mammals. So you find the egg-laying mammals, platypus and echidnas. You find the marsupials, which are the animals that give birth to tiny young and then do most of their growth on suckling milk on a teat. And then you also find placental mammals. So many people think that marsupials are kind of the mammals of Australia, but actually about half of them are placental mammals like us. So they're the mammals that give birth to really large young after a relatively long pregnancy, and then finish off their development suckling milk on a teat. So that's the first reason. But honestly, I was first attracted to them studying in the museum when I was a student in that museum with the specimen in the video, just being taught about an animal that can detect electricity with its bill, that can produce milk without nipples, that can do many amazing things. That kind of was the gateway for Australian mammals for me. And then having spent time there on field work, you can just move kind of 50 kilometers and find a completely different ecosystem, a completely different set of habitats, and therefore a completely different set of mammals. It's a really exciting place.
You're really selling it to me, I have to say. Yeah. And that brings me to my next question. And if you say yes to this, I'm going to feel so jealous. Have you seen a platypus in the wild? And if so, what was it like?
I have seen platypuses lots of times in the wild.
Oh, yeah.
They live all up the east coast of Australia, from the tropics in Queensland down to kind of the icy highlands of Tasmania, which I spend most of my fieldwork in Tasmania, and that's probably the place that they're easiest to see. They vary over that range. They're up in Queensland, they're about 30 centimetres long, whereas down in Tasmania they're maybe a third bigger. And there's quite a kind of nifty technique to look for them, or at least you have to sit very still for a very long time, often in the snow and the wind and the rain. Sometimes in Tasmania, where the lakes can freeze over in winter, you kind of sit staring at the one free patch of water, because you know that's where the platypus will have to surface. But once you spot them, you have to kind of play a game of musical statues, where when they're in sight, you have to stay completely still and completely silent, because they're very, very sensitive to noise and movement. As soon as they dive, because uniquely platypuses have a slit in their head that contains both their ears and their eyes. No other animals do this, but underwater they close this slit, so they close their ears and their eyes, and then they dive and they use their electrical senses to navigate to find food. But when they're underwater, that means you can make noise and you can move, so you kind of give yourself 30 seconds to run as far as you can towards the kind of nearest part of the bank to look for them, and then you wait 30 seconds and then wait for them to reappear, then kind of go through it over again until you're at the closest point. Yeah, they're amazing animals to watch.
This sounds like a great premise for a computer game. Creeping up from the platypus. And yeah, I like the idea of closing your ears off as well. That must be quite a useful thing, I think, for a lot of people. Yeah.
True.
So platypuses look so different to anything we have in Europe. How were they received when sort of news about them first came to our shores?
Yeah, well, so platypuses were first encountered by Europeans in 1798, 99. 1799 was when they were first described by Europeans. Obviously, indigenous Australians had known them for 60,000 years before that. But when those specimens came to Europe, the very first ones were considered a hoax. So the person who wrote the written description of them tried to kind of dissolve any stitching that was attaching the bill to the rest of the body. He thought they were a kind of a taxidermic fake, like kind of the mermaids that were coming out of Chinese ports at a similar time, which were kind of monkeys and fish stuck together, or fish and papier-mâché. So they thought they were fake, but when they realised that they weren't, it was, as you say, unlike anything they'd seen before. So this is kind of one of the main stories I've been researching over the last few years, of how they came to be known and how they were described. And basically, they weren't described very nicely. They were consistently described as very interesting animals, but functionally, they were described as being lesser mammals, being primitive, being lower beings, and just kind of these weird freaks. And people assume, well, actually, the big stories of the first century of platypus science was, could they lay eggs? That the first specimens, people suspected that they could lay eggs with it. They thought that is just something a mammal shouldn't be able to do. It looks like a mammal, it's got fur. They couldn't work out whether it produced milk, which is a defining feature of a mammal, for a long time. And then they thought it might lay eggs. So that was the big mystery. And as I said in the video, we've got the specimens that solved that mystery in the 1880s. But yeah, they were described as kind of amazing and extremely interesting, particularly as evolutionary biology became more of a focus of naturalists in the 19th century. Of just like, how can you have something that looks like a mammal that's got a skeleton that's relatively reptile-like and might produce eggs? How do those things fit together? That shouldn't have worked based on the rules they've given themselves at the time.
Yeah. One thing we still see sometimes is that sort of division of everything into reptiles lay eggs and mammals don't, and it just breaks down, doesn't it? As soon as you start looking at things in a little bit of detail, it all breaks down a bit.
Exactly.
Yeah. So, one last question about platypuses. It's a really hard word to say. Platypuses. Is it true that they are venomous as well?
Well, they are some of the time, and only the males. So the males have these spurs on their ankles, these horny spurs. They're about 2 centimeters long. They're attached to a venom gland. So when they're fighting over females, you can find platypuses that are kind of covered in these holes where they've been jabbed by these very strong spurs. But what's another amazing thing about platypuses is they're the only animal known to produce venom only at certain times of the year. So they are seasonally venomous during the breeding season, and then because I guess it's a complicated set of proteins to produce, expensive proteins, they don't use them if they don't need them. They don't produce them if they don't need them. So yes, male platypuses are venomous during the breeding season. And actually their venom is incredibly complex. It contains about 20 different venom compounds, which are evolutionarily similar to the same compounds that have evolved in sea anemones, in centipedes, in scorpions, in frogs, in fishes, in spiders, in snakes. They've kind of, this isn't how evolution works, but it looks like they've kind of picked the best venom from every other group of venomous animal and mixed it together to create this kind of nasty cocktail, really. And one of those proteins is extremely stable, so it can't be broken down. So that explains why the few occasions that humans have reported being stung by a platypus, the effects can last for over a decade. So people continue to describe kind of muscle wastage and lack of movement and pain 15 years after being stung. So yeah, don't pick up a male platypus during the breeding season. It's the short story.
Yeah, it's probably wise Probably wise not to pick up platypuses unless you really have to, generally. Yeah. So in your film, you also talked about marsupials, and particularly sort of mentioned kangaroos and thylacines, and they are such different looking animals. How many different kinds of marsupial are there?
So there aren't that many. So overall there are about 6,500 species of mammal, but nearly all of them are placental mammals. So we have just about 400 species of marsupial. That's about 1 in 20 of all mammal species known is a marsupial. But they range. There is a great diversity of them. They range from the smallest, which is a long-tailed planigale, to just a few grams. And sometimes when we trap them in what's called a pitfall trap, so you dig a hole in the ground, you put a bucket in it, and then you put a solid fence over the top, and an animal will walk around at night, hit the fence, and then walk along the fence and fall into the bucket, and then we can study it. If a blade of grass falls into your pitfall bucket, then a long-tailed planigale can climb up this one blade of grass. It's that small. So they're the smallest. The biggest today is 90 kilos. But that's because the giant marsupials have gone extinct in the last 50,000 years. So when humans first arrived in Australia, there were these rhino-sized relatives of wombats called diprotodon. We have a cast of a skeleton of them in the lower gallery in the museum, and that is kind of 2.5 tons. So it's a rhino-sized wombat relative. So we're excited to see.
Yeah, I'd quite like to see that, and a giant ground sloth. I think those are a couple of things I would love to see. Yeah. Do we find marsupials outside of Australia as well, or is it just in Australia that you'll find them?
We do. So, as I said at the start, they live in surrounding islands near Australia. So New Guinea is not so far of Australia, and indeed during the ice ages when the sea level's lower, Australia and New Guinea are a single landmass. They share quite a lot of species, or they share a few species, but that's why they live there. And then some of the marsupials go up into the islands to the northeast of that. However, kind of what most people, I guess many people don't know, is that there are also marsupials in other continents. So about 100 species of marsupial live in the Americas. So that's the opossums. There's 2 species in North America, 2 or 3 species in North America. That kind of quite common garden animals, the Virginia opossum. I'm not sure how many people know they're marsupials. And then in South America, as I say, there's about 200 species. Nearly all of them are opossums. And the reason is that marsupials first evolved somewhere in the Northern Hemisphere, either in China or North America. China and North America are periodically connected through, or at least through the Russia and North America are periodically connected. And then they would have got down from North America to South America at the previous time that those 2 continents were connected, which I think was about 50 million years ago. And then South America was connected to Antarctica, so they could go across Antarctica and then up into Australia, which was connected to Antarctica too, until about 30 million years ago. So that's why there are some marsupials in South America. They've gone extinct in the Northern Hemisphere, except for the couple that have recently re-arrived back in North America a few million years ago.
Yeah, it's fascinating when you start looking back in time at these things. It's fascinating seeing their distributions.
There's one of the Australian species has gone back across Antarctica and back into South America. There's one South American marsupial that is more closely related to all the marsupials in Australia than it is in South America. It's the Monito del Monte.
Wow, that's amazing. Yeah. So, how are marsupials doing more generally? I mean, are they threatened species, or are there some that are actually doing okay?
Well, there's not really a nice way to answer that question, I don't think.
Yeah.
So Australia, unfortunately, has the worst extinction rate of any country in the world over the last 200 years. So since British invasion in 1788, at least 33 species, perhaps more, have gone extinct. So that's that's around a third actually of every mammal that's gone extinct in that time. It's gone extinct in Australia, and that is because of many things. Chief among them is the introduction of cats and foxes to Australia. Also rabbits. Cats and foxes eat them, hunt them. The rabbits eat their food, and then introduction of cattle, sheep, deer, buffalo, pigs, cane toads. The conversion of land for agriculture and industry has also taken its toll, and the change of fire management over the last 200 years. has also taken its toll, plus in recent years climate change. So Australia is the only country known to have lost mammals due to anthropogenic climate change. So that's not great news. A couple of species are doing better. The kangaroos enjoy the water bores that have been dug for cattle stations and sheep farming and so they're in greater number. Unfortunately, it's not a great place to be in Australia now, which is a shame because it's the only place that they live.
Yeah. Oh, well, on that rather low note, I guess. But thank you, Jack. That's been really, really fascinating. And I'll not look at our marsupial and monitoring displays in quite the same way again. They're amazing, amazing animals.
Thanks.
So the museum's collections are an amazing resource, but how can we make collections today? One thing that we can do is take photographs of the wildlife that we see. And here are some tips on how to make a digital collection of nature. So that's almost it for this evening. Remember to join us again tomorrow at 7 o'clock when we'll be broadcasting live from the Cambridge University Botanic Garden. We will be exploring how we monitor wildlife today, from studying nesting birds with expert Julia Mackenzie to the insects of Southeast Asia with our curator of insects, Ed Turner. We'll also have some top tips on how you can support wildlife in your own green spaces. But this evening, we're going to leave you with a short film showing just some of the history and some of the amazing collections held here at the Museum of Zoology. So happy wildlife watching.